All right, last time we looked at a function and we talked about its multiplicity. The multiplicity of its zeros and saw what those might kind of look like on a graph. And I posed the question, what if a zero had multiplicity 3? What do we think it would look like? Well, we already said that a zero of multiplicity 2 kind of looks like a little parabola near that zero. Maybe a 0 with multiplicity 3 kind of looks like a little cubic function near the 0. Well, let's find out if we're right. So I'm going to graph, and your book generally calls this analyze the function in a bunch of different ways. But our ultimate goal here is to graph this function. And I'm going to go ahead and start with a polynomial that's already been factored, right? So that we can find its zeros really, really easily. The first thing that I want to do is talk about its degree. This function, f of x, this is of the 4th degree. Why? Well, if I were to multiply out this first factor, I would get an x cubed polynomial, and then when we multiply that by x minus 3, the first term we would get would be x to the 4th. So it's a 4th degree function with a leading positive, or a positive leading, I suppose we should say, coefficient, right? Because it's going to just be x to the 4th, not minus x to the 4th. Yeah. So that's going to tell us something about its end behavior, right? That means that as x goes to infinity, y is going to go to infinity, and as x goes to negative infinity, y is going to go to infinity. So its ends are going to end up looking like this, and it's a 4th degree function, so there might be something happening in between, and that's kind of what we're going to find out. So we'll start by finding its x-intercepts and its y-intercepts. Remember, x-intercepts are also called zeros, okay? So that's going to happen where each function equals 0, but we have to remember about multiplicity. So the first 0 we have is -1 with multiplicity 3, because the original factor was x plus 1 cubed. And then we also have x minus 3 equals 0, which gives us x3, and has multiplicity 1. The y-intercept of this function is, of course, f of 0. Now if I put in 0 plus 1 and cube it, and then 0 minus 3, that's going to be 1 cubed, which is 1, times a negative 3 is a negative 3. So the y-intercept is happening at negative 3. Then we can also talk about turning points, right? This is a 4th degree function, so it has at most 4 minus 1, remember n minus 1 equals 3 turning points. So that's just going to be a check for us to make sure that we don't, have too many wiggles happening, okay? Now I'm going to show you a kind of a cool little trick to talk a little bit more about the behavior of the graph near the zeros. Yeah. So I'm going to take our two zeros. So at near -1, our f of x is going to be approximately x plus 1 cubed times -1 minus 3. So notice what I've done. I took our 0 and I plugged it into the factor that does not involve the place where I got the 0, right? The factor where I got the 0, because that would give me 0 if I plugged it in. And that's going to give me about -4 times x plus 1 cubed. So I see near -1, my graph is going to act like a cubic function. This is a cubic function, like a cubic function. And that's kind of what we said. Remember, a cubic function kind of looks like this or like that. And so remember, we already kind of said that we thought that the multiplicity of 3 of that 0 is going to give us something like a cubic. Notice this leading coefficient here is a negative, and so it's going to be more with the kind of end behavior like this. All right, and similarly, we can look at what happens near 3. Well, near 3, f of x is going to be approximately, 3 plus 1. I'm going to plug in the 3 here and keep this one, x minus 3. Well, 3 plus 1 is 4. 4 cubed is just a constant times x minus 3. So this is a linear function. with actually a pretty steep slope. So we're going to expect the graph to go straight through that 0 pretty steeply. All right, and we're going to take a look at the graph. Now that your book, again, isn't going to ask you to graph at this point, but we're going to take a look at the graph to see that it kind of goes with what we think it should do. Okay, so I've already graphed this one here on Google. The end behavior, notice the fourth degree function, they do both go in the same direction. I have a positive leading coefficient, which means they both go into positive infinity. I have the two zeros here at -1 and here at 3, that is a 0, right? And let's talk about what's happening near those zeros. Notice the function kind of looks like minus x cubed here, or a cubic function with a negative leading coefficient around this 0. And here we do have, the function is going through it very straight, almost straight, with a very steep slope. So it does exactly what we thought. And of course, remember we also said that the y-intercept was 0, -3, and if we look at the scale of this y-axis, 10 is down here, so that looks about reasonable. And of course you can always, Google allows you to look at your x and y coordinates as you move the point around, and if I can get it to stay at 0, -3, we see it right there. Okay.